So when you see this open circle right here, that actually means composition. When I see f of g of x, you've got an outer function and an inner function. So I'm actually going to use two different colors for this. F of g of x. So the outer function is f of x, and the inner function is g of x. So I'm going to write the outer function first, f. So I'm going to put 2, open parentheses, minus 3. And in place of x in f, I'm going to put a g of x. So this is g of x now, which is 5x squared minus 2. So my final answer, I just distribute the 2, and you get 10x squared minus 4, and then minus 3. So then your final answer is 10x squared minus 7. When you go backwards and you do g of f of x, the outer function is now g. So I'm going to start with the function g of x, which is 5 times something squared minus 2. And in place of x, I'm going to put an f of x. And f of x is 2x minus 3. So we do actually have to work that out. 5 times 2x minus 3 times 2x minus 3 minus 2. I'm going to expand that. I get 4x squared minus 6x is minus 12x. And then plus 9 minus 2. And then we're going to distribute the 5 and then add the constant at the end, or subtract the 2. So that's 20x squared minus 60x plus 45 minus 2, so plus 43. And that would be my answer. Okay. For f of g of 1, what I would do is, normally I would say, honestly, we have f of g of x right here, so you could just plug 1 into this function and get it. 10 times 1 squared minus 7 is 3. But I like to do it this way. F of g of 1. So first I plug 1 into g. So here's g. And I say 5 times 1 squared minus 2 is 3. And then we're going to find f of 3. And so I plug 3 into f, and that's 2 times 3 minus 3. And that gives you 6 minus 3, which is 3. Okay. And then backwards, g of f of 1 means I'm going to plug 1 into f first. So I plug 1 into f. So 2 times 1 minus 3 is negative 1. So we're doing g of negative 1. And then I'm going to plug negative 1 into g. So 5 times negative 1 squared minus 2. Negative 1 squared is positive 1, and positive 1 times 5 is 5. 5 minus 2 is 3 again? Did I get 3 twice?
Yeah.
That's boring. Okay. Okay. And then on this one. Now, hey guys, one thing you need to know is that they might use the terminology 1-to-1. Do you know what I mean when I say 1-to-1? A 1-to-1 function means that it passes both a vertical and a horizontal line test. You remember talking about that? So we did that when we talked about finding inverses. If I find the inverse of this, that is 1-to-1. Its inverse will also be a function. Y'all remember that? But if I do the inverse of a quadratic, will its inverse be a function? No, because it doesn't pass the horizontal. Its inverse will not pass the vertical. Cool? Okay. But anyway, they're only going to ask you to find the inverse of functions that you can find the inverse of, so don't worry about that. Cool? All right. So first it says find f inverse, and then use interval notation to give the domain and range of f and f inverse. Again, since they're not going to ask any interesting functions, then the domain and range are going to be easy. So this is technically y, so we're going to switch x and y and solve for y. So I'm going to add the 7. And the inverse of a power of 3 is the cubed root, so y equals the cubed root of x plus 7. Y inverse, I should say. So f inverse of x equals the cubed root of x plus 7. Yeah, okay. It says talk about the domain and the range. Well, if you think about the domain and range of this function right here, so for f, you've got x cubed plus 7. That is just a cubic function shifted down 7. its domain is all real numbers, its range is all real numbers. So its inverses, domain and range, will also be all real numbers. So the domain and range of the inverse become the range and the domain, or sorry, the domain and range of the original become the range and domain of the inverse. And since the cubic function has a domain of all real numbers and a range of all real numbers, so does the inverse. Alright. Oh, the next one is a linear function. So we're going to switch x and y. X equals 6y plus 3. So y equals, I don't know why I did that. So x minus 3 equals 6y. So y inverse, we're going to divide by 6. X minus 3 over 6. I don't know if they would write it like that, or if they would write 1/6 x minus 1/2, divide each of them by 6. But either way, that is your inverse, yeah? Now, this is a linear function. Its domain and range are all real numbers. And so for the inverse, the domain and range switch. But again, they're not going to ask any interesting questions, so are there any interesting weird ones, because they don't work them that way. And so the domain and range are all real numbers. Okay. Number 4. Y equals 3x plus 4 over 2. I'll just go ahead and switch it. So x equals 3y plus 2. I'm going to solve for y. First I'm going to multiply by 2. So 2x equals 3y plus 4. Then I'm going to subtract 4. And then I'm going to divide by 3. And that would be y inverse. Now, again, it talks about domain and range. But if you look at this function, hey guys, everyone look at that function right quick. 3x plus 4 divided by 2. What kind of function is that? It's just a linear function. That's just 3/2 x plus 2. And what's the domain and range of a linear function? All real numbers. So if the original function has a domain and range, I just asked that because a lot of people think, they see the fraction and they think, okay, well maybe it's something weird. It would be weird if there was an x down there, then you have issues. But as it is just a 2, it's just a linear function. So the domain and range of the original are all real numbers, which means the domain and range of the inverse are all real numbers. Okay. Last one on this one. This is y. So x equals the cubed root of y plus 12. I'm going to subtract the 12 over. And the inverse of a cubed root is a power of 3. So y inverse, or f inverse, equals x minus 12 quantity cubed. Okay? To be clear, that does not equal x cubed minus 12 cubed. It's just x minus 12 quantity cubed. Or multiplied out x minus 12 times x minus 12 times x minus 12. But we're not doing that. Okay. This right here is a cube root function of 12. Cube root functions look like this. And then when you shift them up 12, they still look like that. Domain and range, all real numbers, just like the other ones. So the domain and range for f inverse or y inverse is negative infinity and infinity. Okay. Hopefully you feel better about the domain and range of those once you realize that they're not going to ask any ones that have really weird domains and ranges. Okay. It says graph the exponential and give the equation of the asymptotes and the domain and range. So I'm going to need to sketch this, and I'm going to do that using my calculator. Hey Beth, would you mind taping that up there next to that one as well? Okay. So I'm going to go to y equals and type it in. 2 raised to the x plus 3 minus 4. And then what I'm going to do is I'm going to go to my table. And I'm going to make sure it's on normal. Okay. Now, as far as exponential functions go, we should kind of know what those look like. They look like this, and they have a horizontal asymptote. And then the minus 4 means it goes down 4. But you can actually see that just by plotting these points. So I know that at 0 we're at 4. I know that at 1 I'm at 12. You can't even see that. Daggone it. At 1 you're at 12. Did I go minus 4? I did. Okay. To level 12, I'm just going to put a point up there to kind of give myself a goal to get to. So I'm going to go left. At -1 I'm at 0. At -2 I'm at -2. At -3 I'm at -3. At -4 I'm at -3.5. And it should just get closer and closer to -4. So what I'm going to do from there is just graph my horizontal asymptote at -4. And then I'm going to sketch the function and make sure I don't go below that. So I go up. And over here, I go down. Okay, so the asymptote is a horizontal asymptote. And that is a horizontal line through the y-axis at -4. So that is y equals -4. The domain is left and right. It goes all the way left and all the way to the right. So my domain would be -infinity to infinity. My range is low to high. The lowest it goes is that horizontal asymptote -4, but it never actually reaches it, and it goes up to infinity. And there we go. Okay. For this one, we've got negative e to the x and then plus 1. So negative e to the x plus 1. I'm going to look at the graph just to kind of see. And, okay, cool. And then I'm going to go to the table and plot points. Hello. Oh, that's funny. Okay, so it looks like it's really close to 1. And so, okay. At -2, it's, let me get that. At -2, it's really close to 1. And these are all really close to 1, so it's just getting closer and closer to 1. At -1, it's 0.6 something, so somewhere in there. At 0, it's at 0. At 1, it's at -1.7. At 2, it's at -6 point whatever. So -6 point something. Okay, so that's as much as I'm going to be able to see. So I'm just going to draw my horizontal asymptote, which I know is at 1, because it shifted it up 1. And that's at y equals 1. And then I'm going to sketch it. Now, guys, if this is multiple choice, how many times are you going to have to graph by hand? 0 times, right? Okay, just a thought, just a reminder. Domain is how far left and right, so -infinity to infinity. And range is low to high, so the lowest it goes is -infinity, and the highest it goes is 1. It doesn't reach it, though. So there we go. Okay. Hey, when I finish this video, remind me to show you the formulas that they're going to give you, okay? Okay, so find the accumulated value of an investment for $10,000 gosh, 10,000 years, for 5 years at an interest rate of 5.5 if the money is compounded semi-annually. So, semi-annually and monthly, n times, I like to do k times a year, but they use n, so whatever. Amount equals principal times 1 plus r over n to the nt. Guys, you just got to know what those variables stand for. Amount, A. P stands for what, guys? Principal. What does R stand for? Rate. T stands for time. N is this n times a year. Cool? So semi-annually, we're investing $10,000 at 5.5. Did I put in a 5.5 right there? No, that's 550%. So for 5.5%, you move the decimal 2 places. So 0.055. If you work a problem, guys, and you're investing $10,000, and then after 5 years you have $1 billion, that's wrong, and you should know it's wrong. No, it's just bad math. Okay, divided by n, which is the number of times per year. Semi-annually means n equals 2, so that'd be 2, and then 2 again times the number of years, which is 5. So all you gotta do is type that in. So we've got 10,000 times, I did that, 10,000 times 1 plus 0.055 divided by 2 raised to the 2 times 5. And there we go. And everyone knows that on money, we do 2 decimals. And there we go. So for monthly, same thing, only a set of 2 is 12. So I'm going to go up here, and I'm going to make that a 12. And I'm going to make that a 12. Ah, crap. Okay, so that is $13,157.04 if we round up. So just typing that. Now, obviously, you could use the if you prefer it, the 1 plus, and then do the, and it kind of keeps it a little bit closer on the screen so you can see it. But anyway, that's just another way of typing it. Okay. Continuously is the what formula, guys? Yep, PERT. Principal times E raised to the rate times time. So that would be amount equals 10,000 E to the 0.055 times 5 years. And we would just type that in. So 10,000 E to the 0.055 times 5. And you get 13,165. $13,165.31. You can't even see what I'm writing. Okay. Did they leave them as, did they get, yeah, they get the decimal. Okay. Suppose you have $1,500 to invest. Which investment yields the greater return over 10 years? Compounded quarterly or this compounded continuously? So, 1,500, not 15,000. Compounded quarterly for 10 years at 6%, so 0.06, versus 1,500 compounded continuously at 5.75, so 0.0575 times 10. So we're just comparing those two amounts. 1,500, 1 plus 0.06 divided by 4. Hey guys, if you ever find yourself comparing amounts like this, it's never going to be the same interest rate for both, because obviously continuously would make more money. So they're always going to make the interest rates a little bit different, which means you need to make sure and do that. A lot of people forgot that on the test, or to check and change the interest rate. So, okay, so for this one, I got $2,721.03, and for the other one, I got 0.0575 times 10. Taking it. $2,665.70. So which one is better? 6% quarterly. Because that is greater than that.